Welcome back, my dear students. In last class, we were discussing about clay minerals, clay mineralogy, and soil structures. In previous classes, we studied about soil structure, that is your single grain, honeycomb, dispersed and flocculated structures. And after that, we studied units, tetrahedral unit and octahedral units. And after that, we studied about clay minerals, kaolinite, illite, and Mount Mornolite clay minerals we studied. And now, last topic of this module 2.1, that is the second module, first chapter, the last topic, that is your interaction of water and clay minerals. See here, let us consider gravel particles. These are the gravel particles. When you put a water into the gravel, when you put a water here, this water will flow through the gravels. No doubt they will flow through the gravels. And when you take this gravel out, and with a small effort, by taking that cloth, or dry cloth or otherwise, just by blowing some air, just some increasing a little temperature, you can make this gravel dry. That is very easily you can make it dry. Take a small stone, dip into the water and bring it back to the atmosphere, and there you blow some air. If you do like that, then what happens? That water will evaporate and that surface become dry. The same thing will not happen with respect to mud. Say, take some red soil or black cotton soil, then put it into a water, and after that you squeeze the water. Even after squeezing also, the black cotton soil mud, that mud ball will be wet, and you cannot blow, you cannot wipe by the dry cloth, and you cannot little increase in the temperature. You cannot make this soil dry as soon as possible. You would require time. You need to put into the oven for 24 hours, or you need to burn it. Then only this water will be evaporated. Then why that much love is there with water and this clay? Why there is no love between the water and this gravel? Ultimate question. When water comes in contact with the clay, then there will be lot of attraction that will not leave that one. But when it comes in contact with the gravel, it will leave that with a small efforts. Why? Because gravel surfaces are not charged. Charged means what? Positive and negative ions. That surfaces will not have any charged ions in the surface. But when you come to the clay particles have some many reasons, not only surface, many reasons are there. Because of that, clay particles are always charged particles there. Therefore, they attract water. Once they attract, they don't leave those water easily. That is called as interaction of water with clay minerals. This we are studying now. Coming to this, origin of charge deficiencies. See, this is a positive charge and this is a negative charge. When they come in contact with these two, then if any compound is made with these two, then this is called as a charge. This is a neutral. There is no charge deficiency. Therefore, it will not attract any other metal. It will not attract. But when there is a deficiency, when you break it like this, then there will be a deficiency in the charges. Therefore, it will start attracting the other charged materials. In that one, the first point here is imperfection in crystal lattice, that is isomorphous substitution. Very, very, very important. That is the cations in the octahedral and tetrahedral. Octahedral means there will be 4 sides and inside one cation will be there. That is octahedral unit. Like that, this is a tetrahedral and the octahedral will be 8 surfaces will be there. Like this, you already know this one. We studied this. 8 surface will inside one cation will be there, and 6 anions will be surrounded, and here 4 anions are surrounded. Correct? Inside what is there? Cation is there. Okay. That cation can be replaced by that cation, you can remove it out and replace it with other cations, different cations, without change in crystal structure. Crystal structure, without disturbing the structure, you can replace it the other ions. That can be done in stabilization or in mixing the soils with other things. That can be done. For example, if Al3 is there inside, then that can be replaced by Si4 silicon in tetrahedral. In octahedral, what happens? If Mg2 plus is there, that can be replaced by Al3 plus. See, while doing this operation, initially it was a aluminum 3 positive charges that I replaced with the 4 positive charges, means here one extra is there, therefore it will attract, it will start attracting the particles, or charge deficiency is observed here. The same way 2 plus is there, here 3 plus it becomes, means again charge deficiency is there here. These are the main reasons of creating charge deficiency in the lattice, crystal lattice, that becomes unbalanced. Okay, this is the main source of charge deficiencies for Montmorillonite. In Montmorillonite, mineral is always instabilities, always instabilities. Why? Because lot of charge deficiency you will be observing. This you are going to see, that is the isomorphous substitution here. Okay, iso means what? Same. Morphous means what? That what form. Without changing the form, you need to substitute. That is same form substitution, isomorphous substitution. The second very important reason is imperfection in the crystal lattice, that is the broken edges. If this is a mineral, this is a stable mineral, because of some reactions or some physical actions, it may break like this. When it breaks, then these edges, these broken edges are charged, they are unstable. When they are unstable, then they will attract waters, they will attract other charged particles. That is the broken edge can be positively or negatively charged, and they will start attracting. This is the second reason of creating charge deficiency and attracting the water. Now coming to the structure of the clay. See, in the previous classes I told that if you put the clay minerals into the microscope, they don't look like a round, they will be looking like a rodded shaped. I told, I think 2 to 3 times I told, they will be looking like a rodded shape. That you can see here. This is a one clay mineral, one clay particle, and always the clay particles will be in rodded shape, and these edges are these surfaces there. No, these surfaces are negatively charged. These surfaces are negatively charged on both the surface, and the edge may be positively charged, may be negatively charged, depending on which type of clay you are dealing with. Okay, now this is what the clay look like. Now this surface is what? Negatively charged, therefore it can attract positively charged ions. Okay, here it is written external or interlayer surfaces are negatively charged generally, and the edge can be positively or negatively charged. The different cation balances the charge deficiencies. Okay, different cations, they will come and stick to that one. This is how they will always try to attract the other things. Coming to the water, when you know water, we will understand the nature of the water. This water is made up of H2 plus O. But how they will be looking like? They will be looking like this way. This oxygen is the bigger one and hydrogen is smaller one. How I can say? Because oxygen molecular mass is 16 and hydrogen molecular mass is 1. Therefore, oxygen, 1 mole of oxygen is always bigger and hydrogen is smaller to that one. Then they will be always attracted this way. That is 105 degree, one angle they will make, and at that point this hydrogen is sticking to the oxygen. This oxygen is negatively charged and hydrogens are positively charged. Means this surface is positively charged and this surface is a negatively charged. Means water particle both positively charged and negatively charged, therefore we will call it as a dipolar. This positive pole and negative pole, therefore we will call it as a dipolar character. That if you come to the kerosene is not non-polar, it is non-polar. Non-polar means there is no charge in the kerosene. That's why if you put any soil particle or anything, this clay particle only put in the kerosene, they will be that freely they will be settling down. They will not make any mud or any plasticity in the kerosene, but water they will make a plasticity in the kerosene. Clay they will make a plasticity in the water. Understood? This is the nature of water. That is, the water is always dipolar and both positive and negative charges are there on the surface. See, this is a clay. This is what? This is a clay mineral. And the surface, usually what I told, surface is usually negatively charged. But sometimes there might be one positive charge to the surface, but usually negative charges will be there. And this is a water particle. This is a water particle. When water will come in contact with the clay particles, then see, this is the positive, they will come and stick to this particle. They will come and stick to this particle. But here, see, this is a positive, therefore this side will come and stick to the particle. Means either it is that clay particle, either it is a positively charged or negatively charged, but when water will come, that will start attracting that water. Okay, now next, polar molecules, that polar water molecules, this I already explained. Now this bond between the two water molecules, this is one water molecule and this is another water molecule, then this water is a negatively charged and this is a positively charged. This water particle will attract another water particle, but the bond between them is hydrogen bond. This hydrogen bond, I can say that this is the weak bond. This is weak bond. Right? This is what? Water. Therefore, in salts in aqueous solution, what happens? If any chlorine is there, chlorine is negatively attracted. Then when I put the water, then what happens? This chlorine is a negative, but this positive, they will come and attract. But O will be away from that one. Okay, and this O will, what happens? This another water will come and attract like this, and for this another water will come and attract like this. Like that, they will be attracting to the, they will making one solution. If there is a Na such cations are there, there is a positive. In such case, O will first come and attract to that one. Like that, water is a dipolar. Whatever the surface you bring, either it is a positive surface or it is a negative surface, they will attract. They will attract. Understood? That is very important. I will give one task to you people. Do you know that papita? Papaya fruit. That fruit leaves will be there. That fruit leaves will be there like this. If you put a drop of water on that papita, that droplet will run like this. It will not attract to that leaf. There are not only papita, there are many leaves are there. Those leaves, when you put a water on that, they will not attract, they will run like a ball. Why? You just observe this one. Go to the botany or otherwise chemistry, you just answer for yourself. Understood? Now coming to the clay water interaction. How clay and water will be interacting. That is ion hydration, we will call it is. In this one, let us consider two clay particles. One clay particles here and one clay particles here. The clay particles are negatively charged, as I told. And in a dry state means when there is no water, then in between the two clay particles, there will be cations attracted. Might be, there will be two, that cations will be attracted. When I put a water to this one, what happens? When I pour a water between the two clay particles, then water will start entering here. Then here one cation is there. For that cation also the water will be attracted. and for the clay also the water is attracted. Like that, water when it come in contact with the clay particles, even some ions, some cations of other than the clay, there also the water will attract, and even the surface also, the clay surface also attract the water. Okay, when you pour the large amount of water, then what happens, the space between the two clay particles will increase. That's why we will call it as a swelling of the soil. This is called as a swelling of the soil. When summer comes, these will evaporate, this water will evaporate. When the water will evaporate, then they will come in close to each other. That is called as shrinkage of soil. Shrinkage of soil. This swelling and shrinkage of soil will be observed more in Mount Mornolite clay mineral. Okay, see here, and we will be having two types of layer of water which is attracting to the clay. The first one is adsorbed water, and the second one is absorbed. You know, absorption means what? Adsorption means what? Absorption means entering inside the particle, and adsorption means just that what, sticking to the layer, the outer layer of the particles. Always in clay particle, if this is a clay particles, here water will be always adsorbed. Water will be always adsorbed. You will be getting confusion. See, take a small quantity of clay. When you put the water, we say that this clay particle is absorbed the water. Clay mass is absorbed. Absorbed the water we call. But actually speaking, the clay particles, when you take an individual clay particle, it will not absorb. It will only adsorb. Okay, that is very important. See, that depends on mineral to mineral. See here, I considered a Mount Mornolite, and this is a Mount Mornolite mineral, and the thickness of adsorbed layer is something this much. But kaolinite mineral, its solid will be more here, therefore the thickness will be somewhat different, more. You know? Therefore, adsorbed layer in the clay minerals depends on the type of mineral. Okay, then the importance of clay mineral study, why we are going to study this one, is the clay minerals and soil organic matters are collides. This clay minerals and soil particles, organic soil particles, are colloidal means very small particles. Like clay particles is just dust, you know, dust particles are very small, but colloid particles are smaller than the dust particles. Can you see the white particles present in the milk? This is a milk, no? This is a milk. Inside the milk, white particles, can you see by naked eye? No, you cannot see. Take a glass of water and put a one drop of ink into the water. That ink will spread. Can you see the each and every individual particle of ink? You cannot see, because the size of the ink particles are colloidal in nature. Okay, like that they are saying clay minerals and soil organics are colloidal in nature. Therefore, the clay mineralogy, whatever we are studying, that is very important. Then the most important property of colloids is their small size. Okay, the most important properties of the colloid is what? They have a very small size, and therefore the large surface area, the surface area will be large. Then what is the meaning of surface area? Look at here. If one particle is there like this is a particle. Like, I will take one cake only. I will explain with the cake only. I will consider a cake so that you will be easily understanding. Let us consider this is a cake. Cake means this is a bread, it is. Inside a bread is there. Then I want to put the cream out of the cake. Then how much is required? This much cream is required. Then that cake, if I cut it into two parts, then this cake becomes two part. Now bread become a two part. Now the cream required is more, because it has to cover here also, the cream has to cover here also, and apart from that two more surfaces are there here. Here also you need to put the cream, here also you need to put the cream. Means the particle size was a big, the cream required was something, and when the particle size is smaller, then cream required is still more. Like that, see, if I make a small pieces of bread, then how much cream is required? Then cream required for this, cream required to surround this, cream required to surround this, cream required. Like that, you require lot of cream. And when the particle sizes are smaller and smaller, their surface area will be bigger and bigger and bigger. Okay, that is what they are saying, that the most of the colloidal particles are small in size, but their surface area will be very large. When the surface area is very large, then water attracting capacity will be large. See, this is the gravel. When you powder the gravel, that becomes a small powder. Then this small powder require more water to attract the to make it wet. More amount of water is required. That's why you take a that what wheat, wheat you take, put a water, a small amount of water is enough to make all the wheat grains wet, but make this wheat grains into rava. Okay, then you require lot of water to make wet. Then again you make it as a flour, atta, you make it as a flour, wheat flour, you require more amount of water. Then again make it a maida small particles, then again you require more amount of water. Why? Because surface area is increasing, means the water that wetting or otherwise attracting the water becomes more, chemical reactions becomes more. Okay, the soil colloids also carry negative or positive charges on the external and internal surfaces. The presence of charge influences their ability to attract and repulse charge ions to form the surface, to or from the surfaces, that is said. Okay, this is very important topic that we studied till now, right? One more very important here is diffuse double layer, it will come, that I will explain. Okay, there we will observe always two types of layers. We will observe always two types of layer of water which is sticking to the this slide I am using it as a diffuse double layer. Diffuse double layer, I forgot to make a slide on that one. Okay, say this is a one clay particle, right? This is one clay particle, and clay particles are always negatively charged. Surface will be what? Negatively charged. Then if I bring a water to near to this clay particle, that water will stick like this. This you already know. This water will stick like this. Then here what happens? Here the bigger particle will come, that is the oxygen will come and stick. Here hydrogen will come and stick. Like that you will see the water particles coming and sticking to each other. Then if I have another clay particle, then again it is a negatively charged. Then here also the clay particles will come and stick. Agreed? Okay. And this first layer is there, this layer is called as adsorbed layer. Adsorbed, or first layer of water. And this layer we will call it as a rigid layer also. Rigid layer means they are very forcibly sticking to the clay particle. If you want to remove them, then you need to bring this clay particle to near about 100 degrees centigrade. Then only these particles will go away. Therefore they are called as rigid layer. And apart from that, see here also one water particle is there. This is negative, no? Then another water particle will come and stick like this. This is a secondary layer of water. This will come and stick like this. This is a secondary layer. Like that you will get many particles will be, that water particle will come like this, and this is called as a swell. The particles went away from each other, therefore there is a swelling we observed. And apart from this adsorbed layer or this rigid layer, the other layer is called as flexible layer. Okay, and flexible layer is depending on that is a weaker layer. Therefore when more water will come, and this water will go away, and that water will come and stick here. But then again this water will go, this water will come stick here. But these rigid layer water will never go away. This rigid layer and flexible layer together, it is called as a diffuse double layer. Diffuse double layer of water. Okay, now this is what your module 2A includes. Now we completed module 2A, and in the next class we will go to the module 2B, that is compaction of soil. Thank you very much. That is also very easy concept that I will explain through video only. Thank you very much.